All right, we'll take a look at a couple more examples here. Um, we're going to graph each solution set for each linear inequality on a Cartesian plane. That's just an XY axis. In part B, they add another wrinkle that we're going to have to worry about, but we'll get there. So for the first one, we're given the equation x minus 2 is greater than 0. We can rearrange that to get x all by itself. X is greater than 2, right? We're just going to add 2 to both sides. Now, so we have our point at x is 2. Because there's no little line underneath our inequality symbol, we need to draw a dashed line. So we grab our pretend ruler again. We're going to draw a dashed line through the point x is equal to 2. Now, all points x are greater than 2 will fit. So we can shade in everything over here greater than x is equal to 2. Right? But we have to make sure that our line is dashed because x cannot equal 2. If we had the little line underneath, x could equal 2, and then we would have that solid line. Now, if we look at part B, we're given the equation negative 3y plus 6 is greater than or equal to negative 6. So we want to get y all by itself. So we're going to start by subtracting 6 from both sides. So we got negative 3y is greater than or equal to negative 12. We're going to divide both sides by negative 3. And when you're dealing with inequalities and you multiply or divide by a negative number, you have to flip the alligator. So y will be less than or equal to 4. So we find our spot, 1, 2, 3, 4. It's going to be a horizontal line. Grab our ruler. And because there's that little line underneath, right, as y is less than or equal to, we can draw a solid line. And since its y is less than 4, we can shade in all of the area underneath. But we have to look at this. Right, in our first example, x and y were elements of the reals, so all of the little points in between were okay. In part B, just to make things complicated, they're saying x and y are elements of the integers. So we can only have whole numbers. We can't have decimals or anything like that. So to show that, we actually have to, theoretically, stipple. So we'd have to draw little dots at each intersection to show that, in fact, we can only have those whole number answers. Now, I don't expect you to stipple the whole thing. That's just tedious. As long as you do enough to show me that, yes, that whole area should be stippled. Now, this also will come into play if we had like a real life example where we had whole numbers of cars or bananas or whatever it is that they like to throw into math equations. So that's what stippling looks like. You only have to stipple if it's x is an element of the integers or the whole numbers or something like that, or if we're looking at a real life example where we can't have partial units.